So we are directly jumping to the next session. The next session is presented by Dr. Kim Nilsson, who's chair and co-founder of Pivigo, and Robert Grieg-Gran, who's co-founder and COO of Mindful. And they're talking about recipe for innovation. And the talk is about recommending recipes based on adventurous. And I'm very happy to hear their thoughts, their considerations. The stage is yours.
Thank you very much, and thank you for that introduction. Yes, right in time for lunchtime across Europe. Let's talk about some mouth-watering recipes and specifically how we can recommend them so that individuals can find the recipes that they're interested in. Yes, my name is Kim Nilsson. I'm the chair and co-founder of Pivigo, and with me I have Rob, who is muted.
Fallen at the first hurdle. Hi, good afternoon, everyone. I'm one of the co-founders of Mindful Chef, which is an online food delivery business. We operate in the UK. We've delivered about 10 million meals across the country, and all the ingredients that you need to make a really healthy, delicious evening dinner. In how this project started is in 2019 now, we asked Kim and her team to help us get better at recommending recipes to customers. Typically, we have a menu of about 40 recipes a week, and we thought we could do a better job at suggesting what customers wanted to eat to them. And so we asked the team to help us out.
Indeed, and maybe if we can just go back for 1 second to the slide to introduce Pivigo as well. So Pivigo is a UK-based, but also have a German subsidiary data science marketplace, and we work with organizations to help them do their data science projects by connecting them to a global pool of data science freelancers. And we've completed over 250 projects with about 150 different clients. Typical projects being optimization, predictive maintenance, and recommendation systems like this one. So indeed, what was the problem you came to solve, ask us to solve, Bob?
So the problem that we came to solve was really one of how do we get better at sort of personalizing our service towards the customers. So if they have lots of recipes to choose from each week, we want to be able to deliver them the ones that they're most likely to enjoy, and therefore hopefully keep them as customers. And I think the problem that we also set was we need this to be that's good timing, isn't it? We need this to be a productionized API version. Over to you, Kim.
Yes. Well, when you work in a warehouse, you will unfortunately have some background noise. So what we had were 3 challenges when we started with this. So we wanted to help customers find the recipes that they were interested in. The first 2 recipes that they would see on the screen were always automatically allocated from a random sample. But beyond that, how can we recommend the recipes that they will be interested in to order new boxes every week and to become regular customers? And there were 3 specific challenges in all of this. So the first one was that we have no overlap between menus. The Mindful Chef team are always constantly developing new recipes. And therefore, this is not a problem like a Netflix recommendation problem where the content stays more or less the same at any point. And you could say that, well, customers like you also like this, therefore we recommend it to you. That was not possible in this case. We had a cold start every week with new recipes. So that's challenge number 1. Challenge number 2 is that this is a multidimensional space. If we think of each recipe and the features attached to them in terms of ingredients, steps, number of steps, part of the cooking, how difficult it was, the difficulty level of the recipe, etc., there could be 10,000 features associated with just one recipe. And if we then, of course, also take into account that the user is unique and has its own history, has its own preferences, in total, combining all of this, we could end up with a feature space with 100,000 features combining. And how do we even start with that high dimensional space, working with that? And the third problem was what we call the Big Mac problem. It's very easy to start recommending the same item, the same menu that a user has liked before, because we know they like it. And so a recommendation system always has the challenge of challenging the user to see something new and try something new. But if we start with the second problem there, and we want to map this onto a lower dimension, the team came up with a novel way of creating a new two-dimensional space where they mapped all those different dimensions and all those features onto the space. And we had 2 dimensions here. We had meatiness and soupiness. And so you can imagine that chicken soup, beef soup, that's very meaty and it's soup, so it's in the top right corner. We have lamb chops, chicken drumsticks, they are meat, but they're not soup, so they're at the bottom right corner. Tofu is no meat, no soup, and then vegetable soup at the top left. And so in this way, we could take all of those dimensions and reduce them onto these 2 dimensions. Now, if we create 2 new recipes, we can easily map them onto these slides and onto these 2 dimensions and say, where do they sit in these 2 dimensions? And then we can start to look at how do the customer move around the space? How relevant are these different recipes to each other? And this putting it into these 2 dimensions means that we have solved the problem of the high dimensions, because we can now work in 2 dimensions. And then the question is, how do we tackle and it also solves, by the way, the fact that it's new recipes every month, because we can now map them onto these 2 dimensions. But how do we try to solve the third problem, the Big Mac problem? Well, as I said, we can look at how a customer moves around this space from one order to the next. Are they the type of person who prefers to stay in their comfort zone and will take very small incremental jumps within this 2-dimensional space? Or are they really adventurous people who like to make big, bold moves and try new things? And so that was a hypothesis from the data science team that actually this could be important to see how people move around the space. So the team then started to look at what was the feature importance here, what really mattered to the customer. And lo and behold, they found that the 2 most descriptive features here were, in fact, delta 1 and delta 2, the average size of the jumps that the customer had done in the last couple of weeks. The curiosity parameter here is a combination of the 2. So really, how far does the customer like to move in this space, in this graph, in this ingredient space at any time? And these 3 were the top ranking factors that decided what a customer would order the next time around. And it was quite surprising that those features ranked much higher than, for example, what type of protein it was, how many calories it was, or any other dimension that to us would make sense as being important and relevant. But how do we actually now measure the success of this recommendation system? It's not as easy as a Tinder swipe, yes, right, no, left. It's more about ranking. We can show the customer every week a set of recipes that have been developed for that week, and the customer has to rank from the one they say, we want this one, maybe want this one, really don't want this one. And so the success metric in this case that the team used was map at K, which is a sorting algorithm. And they then applied several different factors to see how well can we do in recommending content based on these new dimensions. Now, the baseline here is complete randomness. We're going to show the customer complete random samples of recipes, and they will order something. And before we even started our project, Mindful Chef already had their own rules-based way of recommending content, which already did 15% better than random. So the target was to improve on that. And the team then looked at 3 different types of algorithms for this. They used logistic regression, they used neural networks, and they used random forest. And each of those in turn did better than the baseline and also did better than the Mindful Chef own algorithm. And in fact, the random forest, which was the best one in this case, does almost 4 times as good as the original Mindful Chef recommendation. So great success in showing that these new dimensions can do better than the traditional model. The random forest plus here, that was a case of where the team at the end of the project decided to add a few more features into the mix and actually did end up with a better result in terms of predicting what the customer wanted. But they didn't have time to productionize that, and therefore that was sort of left out in the end, because it was important also for the team to make sure that they delivered something that was immediately applicable. So they put all of this code into a Docker containment with an API where Mindful Chef can just put in a JSON file with the recipes, with the user information, and immediately get an output recommendation of which recipes to recommend to the user.
Yeah, we were, from a business perspective, we were really thrilled and amazed by the outcome of the project, that it wasn't specific factors about the recipes, whether that be high carb, low carb, the types of proteins, the cost of these recipes that influenced customer behavior, but actually to see that the most important factors were really around the customer themselves, how adventurous they were in trialing our range and how they like to eat different things week after week. And it allowed us to really start to think about our customers in a different way, from the ones who always buy, a chicken breast every single week, to the ones who are dotting around through the menu and really looking for that discovery element through their customer experience. And I think our sort of hope with the model and using this recommendation to try and lure customers to make another purchase because we can show them recipes that they really want to eat, was of course to drive increased purchase frequency. So to try and drive a customer to make one more purchase in a year, improving retention, or really boosting customer loyalty. And then I guess a couple of the other sides that not so obvious from the outset for us was actually to look at recipe design and menu design, because using the same model, we could then say, okay, well, based on the current customer base and based on what the model is saying that they are most likely to choose, do we have the right recipes on the menu for any given week to hit the maximum number of customers? And so therefore, we use that to backdate ourselves and do improved recipe design. And we also then use the same model to think about how we might demand forecast and what customers might choose in any given week. When we ran the maths on the performance of the data science model versus our existing model, what we knew is that the attrition rate for customers who made active choices ran around 4.3% on a sort of weekly basis of, making a purchase within 7 days, another purchase within 7 days. And on our existing model, if we just let our existing model choose the recipes and the customer didn't make a choice, it would run about 3% higher. And so we estimated that with a 30% improvement on the auto allocation, on an annual basis, we'd end up making another sort of 1.6 additional deliveries to a customer, which back in 2019 with our customer base was still a fairly large number, and now in 2021 it's a very big number indeed. So to summarize the presentation, we set our data scientists a challenge of how to build a personalised recommender system that, on the output of a relatively short project, outperformed our current framework by about 30%. We were delivered a fully productionalized model that can be retrained and is actually deployed and communicates with our APIs. And I guess we provided a very solid investment case for the impact of data science in a fast-growing startup that had never really delved into data science before. And actually, given that we were meant to do this presentation last year, in the time that's passed, we've actually done a follow-on project where we looked at onboarding and brand new customers. So the existing model that we built the first time around worked wonderfully for customers where we had a long purchase history. We understood how they moved around the feature spaces and could therefore design a menu that they would really want to buy from each week. But we knew that for a brand new customer, we had no order history. So the next challenge was to say, allow the customers to play a game, play 60 seconds maximum, and make some selections using some sort of gamified method to allow us to build a fake order history and therefore start them into the recommender. That one also great success. It's yet to be used in production on real customers, but our team have played with it, and it's definitely in the pipeline to be built. Thanks very much.
Thanks a lot for this very interesting insights in your corporation. So maybe one question one could ask is, what are future projects of corporation? What are next steps, or what are potential other use cases where you can predict customer behavior in the mindful ecosystem, or even in other ecosystems as Pivigo? So where can one use those kind of setups in which kind of business environments in the future?
I know a project, I can already say, a project that we're starting on now with the two organizations working together is to build on this work and really build it into a customer churn model. So again, multi factor, lots and lots of data inputs to really try and give us a sense, a traffic light system of how likely do we think a customer is to make a purchase next week, next month, next year, and to feed that back into both our sort of, our CRM systems, our loyalty programs, and potentially our recipe and product design. So we can say, well, actually, we've spotted that customers who don't make an active selection on the menu, who haven't opened an email recently, who haven't or who haven't referred a friend, might be quite likely to churn. Whereas if we can get somebody to leave a positive review about a recipe, make active selections, they're engaged in their emails, maybe they're very on a green light system, and so we can leave them alone, and we don't need to sort of throw loyalty gifts at them to keep them in the ecosystem.
Yes, and any digital subscription business, which of course is a growing market, not just for food, but for all kinds of different products, clothing, beauty products, etc., or even just digital products themselves, like content. Any such company will care about churn, because everyone knows it's cheaper to keep a customer you already have than to find a new one. And so this sort of recommendation combined with churn modeling should be at the heart of any subscription business online today.
I think that answers the question in the chat regarding wealth management perfectly. So thanks a lot for your insights in your corporation. And
thank you.
I wish you all the best for your future corporation.
Thank you.